Hi, welcome back. You might recall that we discussed about unsupervised learning method and clustering methods as well. So one of only clustering method we talked about was k-means, right? And we have shown that k-means is a variant of the expectation maximization method, right? And the Gaussian mixture models. We used Gaussian mixture models to interpret k-means. Okay. Now, one thing that would certainly help is to walk through an illustrative example which shows how to apply k-means. So just to recall, it's an hard assignment of any point to the cluster mean, right? And the cluster means are iteratively computed. Okay. And when we see a very low divergence between the means of points, means of a cluster and the points belonging to the cluster. So the variance within the cluster when it's really low and the variance between the clusters when it's really high, that's where we decide to stop, right? So, just think about this as a bi-objective optimization problem where you are doing two things. You are minimizing the variance inside the cluster. So it's an intra-cluster variance that you want to minimize and maximize the inter-cluster variance. Just as a side note. So you minimize the intra-cluster variance and maximize the inter-cluster variance. Okay. So just let's take so the idea is we start by picking k centers or k means at random locations, right? So we start by picking k means at random locations. Okay. So just let's take a look at the data. Okay. So I have, and this is just the first step. Okay. All right. So this is step 0, really. Okay. Where we have some 5 data points. Okay. With the feature values, and we'll just take a 2-dimensional example, right? A, B, C, D. Okay. All right. So, if I, let's take a look at a 2-dimensional representation of these data points, right? So the point A is somewhere over here, right? It's like 1, 1. So this is point A, right? Point B is at 1, 0, right? So this is point B, right? Point C is at 0, 2. So this is where C is, right? 0, 2. Point D is at 2, 4. So, and E is at 3, 5. So, somewhere over. Okay. So, intuitively, it sort of looks like, these guys, A and C, they can be chosen as cluster means intuitively. Why? Because the only other point other than A which are sort of really close to A is the point B, right? Okay. So, and then compared to A and B, the point C seems closer to the other 2 points D and E, right? So it's sort of like, this is just a guess. Okay. This is just a guess. It may be true, it may not be true, but like sort of looks like, the candidates for the 2 cluster, at least to begin with, these are no way the final clusters, but at least to begin with, these are the 2 candidates. Okay. Okay. Now I'm not really sure whether these are really, whether this is really a good assignment or not, right? So we don't know. So it's like there is no guarantee this is a good assignment. So therefore we iterate, right? So therefore we iterate. Okay. All right. So the next step. So this is the first, I have the data points, right? So the next step is this. So step 1 is where we compute, the means. Okay. All right. So we know the position of each of the data points, right? And so since we decided that A is the cluster mean, right? I mean, just randomly. So basically what we have done, we have basically chosen K to be equal to 2. Okay. All right. So we decided that A and C, these will be the means. Okay. All right. So 1, 1 is the mean of the cluster around A, and 0, 2 would be the mean around the cluster C. Okay. All right. So what we do is, the next step is, do this again, right? A, B, C, D, and E. Okay. All right. And then we have keep 2 columns. Okay. The column 1 is where we contain the distance between the observation, okay, and the mean of the cluster 1. We know the mean of the cluster 1 is 1, 1, right? So we compute the distance. Okay. So the first column, and then what do we do in the second column? We do the same thing. We have the observation, so you compute the distance between the observations and the mean of the cluster 2. Okay. All right. So what we do is we compute the distance between observations and mean of cluster 1. And here we compute the distance between observations and mean of cluster 2. Okay. All right. So, I mean, if I do that, I mean, it's kind of easy to see that this is 0 and 1.4, right? Okay. And at least let's do it in the first column, right? We'll do it in the second column later, right? And for this one, right, the distance is like, I mean, the mean is 1, 1, B is 1, 0. So what would be the distance? The distance between 1, 1 and 1, 0 would be, 1, right? Take the square root of it. So this is 1. Similarly, the distance between, the observation C, which is 0, 2, and the mean of cluster A, which is 1, 1, would be what? 1 and 1, and so square root of 2, which is 1.4, right? Similarly, if I continue, I'll just have these values over here, right? Okay, and let's do that for the second column. Okay, so what are we doing in the second column? In the second column, we are computing the distance between the observations and the mean of the cluster 2. Now the cluster 2 is C, right? I mean, we decided that C would be the mean of the cluster 2, right? Okay, so that is, the mean is 0, 2. So we compute the distance between all observations and this guy. If we do that, we will get these numbers. I'll just copy those down. You can easily verify. For C, obviously it's 0, right? This is 2.8 and this is 4.2. Okay, all right. Now we have these numbers, right? So what do we do with these numbers then next? So look, our first cluster was A, right? I mean, we kind of just started with A. We decided that A would be the mean. What is the closest to A? The closest to A is A itself, because between these two values, this is the smallest, right? So therefore, what we do is we assign this to cluster 1. What do we do with the next row? Well, once again, between these two, this is the smallest, so we assign this to cluster 1 as well. Okay, the remaining 3, right, 1.4, 0. Let's see, 1.4, 0, and the mean was 0, 2, 3.2, 2, 0.8, 4.5, to 4.2. These are the, okay, so it's sort of, so these 3, what we do is we assign to cluster 2. Okay, so what this means is that A and B, so therefore A and B are in cluster 1 and C, D and E are in cluster 2. Okay, alright, so we have the new clusters, okay, and see, when we began, our cluster had just only 1 point, right? I mean, now we have 2 clusters and one cluster has 2 points and the other cluster has 3 points. So obviously the mean will be changed, right? Now the mean will change. The mean will no longer be for the cluster 1. The mean will no longer be at A. For the cluster 2, the mean will no longer be at C. So you have to recompute the mean, right? Okay. So that's what we are going to do next. Okay. Which is step 2. So in step 2, okay. So in step 2, I will just, copy those down again, right? I mean, for some reason, I'm just drawing really fat tables, but that's all right. Okay. Now, I just copy down from step 0, right? I'll copy down these numbers from step 0, right? Okay. So these are like 1, 1, 1, 0, right? And these two belong to cluster C1. So need to recompute the mean, right? So what would be the mean? The mean would be 1 and 0.5, isn't it? Right? So it's 1 and 0.5, right? These three guys are 0, 2, 2, 4, 3, 5. Okay. So therefore, I'll recompute the means. So it's like simple, right? 5 divided by 3, which is 1.7 approximately. 2 plus 4, 6 plus 11. So 11 divided by 3 is about 3.7, right? So the second cluster has recomputed mean, and which are 1.7 and 3.7. Okay. And therefore, I mean, I go back. I mean, I just basically, this is my one cluster and this is my other cluster. Okay. All right. What do I do next? Basically do the same thing. Once you have recomputed the mean, you will replicate step 1. So, I mean, step 1 now would become step 3, where you would compute the distance between each observation and the mean of cluster C1. Keep it in column 1. Do that in column 2, where you compute the distance between each observation and the mean of cluster 2. Okay. All right. We know these means, right? So the previous means were 1, 1 and 0, 2. The updated means are 1, 0.5 and 1.7, 3.7. Okay. All right. Okay. So, I mean, probably what I should do is I would write a record of it somewhere. So let's say the x1 0 and x2 0, implying the cluster means at the 0 step are 1, 1 and 0, 2. However, when we have updated and recomputed, I have updated my iteration number. I should update it, right? And I should rewrite it as 1, 0.5 and 1.7 and 3.7. Okay. All right. So far so good. So let's go to the next step. Okay. I'll probably need to erase something, which I wonder which one should I do it. Let's do it. Let's do this one. So I'll just need to. I don't have to erase everything. So just erase the numbers. Right. Okay. All right. So what I'll do is we'll do the same thing, right? I compute the distance between observation and mean of cluster 1. Okay. And just do it in, record it in 0.8, 3.6, 4.9, and in the second column do it for observations and mean of the second cluster, and then rewrite this as 2.7, 3.7, 2.4, 0.5. Notice very likely you will not have 0 entries now. the reason why you had 0 entries before is because you were actually, you took your observation as a cluster mean to begin with, right? All right. Now, what will happen is, I'll compare this with, so this is the lowest between the two, this is the lowest between the two, this is the lowest between the two, right? Okay. So these three guys will become my new cluster. Okay. All right. And the other two, okay, what will happen is, because see what is happening here is that when you are comparing between the rows, the lowest values are, at least in the first 3 rows, the lowest values appear in the first cell. Okay. Here, here, and here. Okay. And implying that the values corresponding to those, the coordinates corresponding to those, should belong to cluster 1. Okay. All right. So this is in cluster 1. However, when you are comparing the same row, the rows in 4th row and 5th row, I mean, what you will see is that the lowest values appear here in the second column, and therefore D and E are now reassigned to cluster 2. Okay. Visualization will change now, correct? So what I'll have is, I will no longer have the clusters that I originally envisioned, but rather it will change, correct? Okay, right? And so what I'll have now is new cluster orientation. So I have these three guys are friends now, okay, and these two guys are friends. So I have new clusters with A, B, and C, and D and E. Okay, all right. So therefore, I mean, if I may, just for clarity, okay. So your new cluster now has 3 data points: 1, 1, 1, 0, and 0, 2. Seems reasonable, right? Okay, and the other cluster has 2 data points: 2, 4, and 3, 5. Okay, all right. So what's the next step? Recompute the means. Okay, so what will happen is, I'll recompute the means. So this will be step 3. We'll recompute the means. Okay, and if I do that, you will see that this is 0, 2, 1, 1. So your x1, you will update the means as x1 2, x2 2, right? And those will be 0.7 and 1, and 2.5 and 4.3. Okay. All right. Now, what are you going to do? When are you going to stop? Okay. Now, the following step would be just replicate the step 2, which is, once you have the means, right? I mean, you measure the distance of each observation from the new cluster means. Okay. For the cluster 1, you store the values in column 1. For cluster 2, you store the values in column 2, right? Okay. Now, if you see no change in the reorganization, I mean, in the organization of the data points, I mean, after doing the next step, if you see that the cluster 1 still contains the points A, B, and C, and cluster 2 still contains the points D and E, that means, I mean, no further reorganization is necessary, and you have the points optimally allocated to the 2 clusters, and that's where you stop. Okay, so you observe no change. Next is recompute the means, and then the next thing is compute the distances again. The distances again. Observe no change, right? What you do? Stop. Observe no change, and we stop. And you can say that your clustering algorithm converged. Okay. So I wanted to show this as a supplementary, to the k-means discussion, where we computed the cluster means. We show that the cluster means is sort of a distortion function which you minimize, and when you minimize, you actually converge towards the sample mean of your data points, which is the principle which we have applied here. We just used the computed and recomputed the sample means. Okay, and then we finally arrived at the conclusion that the convergence happens at the sample means. Okay, all right. Okay, this is what I wanted to talk about k-means, and the next topic would be k nearest neighbor, which is an instance based learning.